Picture this. You step outside at night, and the sky is moving. Green rivers, purple curtains, sometimes even red flames, far from the poles. And here's the weird part. 2025 is one of the best windows to see that in decades. So why now? What has to happen on the sun for the sky to light up like that? Most people think auroras are just a cold places thing. Like you go to Iceland, you wait, and boom, northern lights. But auroras aren't really about cold. They're about the sun, and about Earth acting like a giant magnetic shield. The sun isn't a calm lamp in the sky. It's a boiling ball of plasma. Magnetic fields twist, tangle, and snap. And when they snap, the sun throws energy into space. Sometimes it throws a little, sometimes it throws a lot. And when that solar stuff hits Earth, the sky can glow. So what's different in 2025? We're inside something called solar maximum. It's the peak of the sun's roughly 11-year activity cycle. During this phase, sunspots multiply. And sunspots are basically the sun's trouble spots. Think of them like pressure points. When they get unstable, they break. And that break releases energy in two big ways. First, solar flares, a burst of radiation. Fast, basically at light speed. Second, coronal mass ejections, CMEs, semis. These are huge clouds of charged particles. They travel slower than flares, but they carry way more matter. Now here's the key. Auroras happen mostly from those particle clouds and also from fast solar wind streams that blow out of coronal holes. So, what happens when that hits us? Earth has a magnetic field. Imagine a force bubble around the planet. Most solar particles get deflected, but near the poles, the field lines open up. They act like funnels. They guide particles down into the upper atmosphere. And when those particles slam into oxygen and nitrogen up there, those atoms get excited, then they relax, and they release light. That's the aurora. Green comes mostly from oxygen, about 60 to 100 miles up. Red is oxygen even higher up. Blue and purple come from nitrogen. So the colors are literally Earth's air glowing. Kinda beautiful, kinda alien. So why can people farther south see auroras more often right now? Because during strong geomagnetic storms, Earth's magnetic shield gets squeezed. The auroral oval, that ring where auroras usually form, expands. It slides toward lower latitudes. So places that almost never see auroras suddenly get a front row seat. And during solar maximum, those storms happen more often. Not every night, but enough that 2025 is a real opportunity window. So, does that mean the sun is dangerous right now? Most storms are just pretty. They make satellites wobble a bit, they mess with radio for a while, then they pass. But once in a long while, you get a monster. The classic example is the Carrington event. Back in 1859, a massive solar storm hit Earth. Telegraph wires sparked. Some operators got shocked. Auroras showed up near the tropics. So, what if that happened today? We're way more dependent on space tech now. GPS, satellites, power grids, internet timing, long-distance flights. A Carrington-level storm wouldn't end civilization, but it could cause major blackouts, satellite damage, and navigation trouble. Think weeks of chaos and repair, not the end of everything. So, solar maximum is a double-edged deal. More auroras, more risk, same physics. Okay, how do you actually catch one? Space weather centers track storms with something called the KP index. It runs from 0 to 9. 5 means a real storm. 7 or higher is, wow, look south now. You don't need to be a scientist. Just check an aurora forecast before heading out. Then you need 3 things. 1, dark sky. City lights kill contrast. Go somewhere rural if you can. 2, clear weather. Clouds are the true final boss. 3, Patience late at night. Often the best window is around 10 p.m. to 2 a.m. local time. And here's a fun trick. Your phone camera can spot faint auroras before your eyes do. Long exposure pulls out the color. So if you think you might see something, take a quick photo. Sometimes the camera reveals the whole dance. Let's recap fast. Auroras happen when charged particles from the sun collide with Earth's atmosphere. We're in solar maximum now, so eruptions are more frequent. That pushes the auroral zone toward lower latitudes, so more people get a chance to see the lights. It's a rare, sweet spot for sky watching with a small side of space weather danger. Now, I'm curious. If you could see an aurora anywhere on Earth just once, where would you go? And would you rather catch a gentle green glow or a full-on red-purple storm that looks like the sky is alive? Tell me in the comments, and if you want, I can make a follow-up on the strongest solar storms we've ever recorded and what the next one might look like. Quick glossary before you go. Solar maximum means the most active phase of the sun's 11-year cycle. A CME, coronal mass ejection, is a huge cloud of charged particles thrown from the sun. The KP index is a 0 to 9 scale for how strong a geomagnetic storm is. And the Carrington event was the biggest recorded solar storm in history.